So let f of x be a function of period 2 pi. Then f of x is defined piecewisely, such that from minus pi to 0 is 1, from 0 to pi is 0. So the first part of the equation is to sketch f of x in the interval. Part 1 is minus pi to pi. Part 2, x from minus 2 pi to 2 pi. Part 3, x from minus 4 pi to 4 pi. And then second part is to find the Fourier series of the function from minus pi to pi. And then to use the Fourier series to find the exact value of the series 1 minus a third plus a fifth minus 1/7 plus other several terms taking the same pattern. These are the kind of questions expect in this chapter. And it's very easy to score the marks if you follow every step correctly. Especially on the first part of sketching. The key information given in the question to help you get the question correctly is that you have been told that the period of the function is 2 pi. Means the number of times the graph repeats itself, or we have a complete cycle for the graph. So to sketch this graph from the interval or from the value of x minus pi to pi, we clearly see that the way the function is defined, if we move from minus pi to 0, then f of x takes value 1. And when we move from 0 to pi, f of x takes value 0. So therefore, we can have this, the solution. For the first part, we want to sketch f of x from minus pi to pi. So I'll take this as my y-axis or f of x, and then draw the x-axis. And then let me label this as 0. Let me label this as 1. Let me label this as minus 1. And let this be pi. And let this be minus pi. So clearly in the question, we know that the value of the function, when you move from minus pi to 0, you get 1. So which means?
Straight line.
That's a straight line. So you draw a straight line from minus pi to 0. Pick a different ink. So that would be the arm. And if you want to be even more exact, you can actually draw a small hole at this point and also draw a small hole at this point, just to see that the inequalities were strict inequalities. But even if you draw a complete line, there's no problem. But you can as well put that small hole to show that x value is not defined at exactly negative pi and 0. But even if you make it complete, no problem. And then from 0 to pi, the value of the function is
0.
0, 0. So then we'll have this. Or if you want to be specific, you can draw a small hole at this point, just to insist that the value of the function x is not strictly at those endpoints. But even if you draw it as a complete line from 0 to pi, is still okay. So this is the answer to the first part. So the second part, is from minus 2 pi to positive 2 pi. So let me draw this as my x-axis. Let this be our y-axis. So this is 0, say this minus pi, this minus 2 pi. So this is pi, this is 2 pi, x. So say this is 1. So this minus 1. Please note that sketching in math means you draw something that is to scale, and you know the properties on how to draw a graph. So if you are provided a graph paper, then ensure that if you are doing the sketching, then the sketch should occupy at least 3/4 of the grid where you're drawing. All those things that you know about drawing graphs still applies here. Now, the first thing we know that the value of the function from minus pi to 0 is 1. So draw that arm. So we have 1. And then from 0 to pi, we know that the value of the function is 0. What is the starting point? So let me draw. You don't have to pull this, but then I just want to pull them so that I illustrate how to complete the graph, these dotted lines. Remember, when you are told that the graph or the function has to period 2 pi, then it means that the graph repeats itself after 2 pi number of steps. So let me label this point. You don't have to label in your book. I just want to do this for illustration purpose. This point A, this B, this C, this D, this E, this F, this G, this H, this I, this J. Remember, we have been told that f of x has period 2 pi. Now, where would be the image of this point I? If I have to move to the right, why I will be mapped to which point? So that we have 2 pi difference in steps. Or where, if I take this as point H, where will I, what would be the image of H to have 2 steps or 2 pi steps? Would that F. And then where will be point I? I will be at. I'm moving this direction. Where will be point I? To have 2 pi steps from where it is at G. So therefore, we'll draw another arm here. So that's already taken care of in the right-hand side. So which means then these are the arm now. We have to go the other direction. So where do we take point C to have 2 pi steps from where it is? This point C. How should it move so that I have 2 steps from where it is to the left? At point A, correct. And then point D will be taken to which point? B. So therefore, another arm is at this point. So therefore, this is the complete graph for that given. Remember, these are not this labeling are just labeling them just to enable us to do the location of the points, but it's not part of the solution. What is important is the lines we are drawing in these graphs. So these letters are not part of the solution. So that is now the complete solution for that given part. Can you now be trusted to draw the graph up to 4 pi? Are you able to complete up to 4 pi and negative 4 pi? Okay. I don't want to draw another graph. I'll use the same graph to extend it to minus 4 pi and pi. So let me extend this. So let's say I have 3 pi, then I have 4 pi. Say minus 3 pi minus 4 pi. It is still the same function, so period 2 pi. So at -2, where should I move so that I have moved 2 steps from where it is? If I'm going to the left. If I have to move to the left, then minus the point where I have minus 2 pi should be taken to which point?
1 to 1.
Remember, the steps are 2 pi steps. So I'm at minus 2 pi. So if I have a gap of 2 steps, where am I going to stop?
-3 pi.
At? I'm saying if I call this
F1.
point A, I call this point B. I say this is C, this is D. So if I'm moving to the left-hand side, where will A be mapped to? For it to have 2 steps, a 2 pi steps difference.
D.
D. And then where will be point B?
C.
C. So therefore, another arm of this graph will be from minus 4 pi to 3 pi. And then if we still have this, so the top of this point B will be taken to the top of
Point C.
Point C, correct. And then the top, if I call this 0, top of 0 will be taken to
B.
top
A.
of
A.
A. Because if from this point here,
A.
2 pi steps will be actually on this line here. So I'll have another arm at this point. And then top of this point, 2 pi will be top of which number?
4 pi.
4 pi, correct. And then top of pi?
3 pi.
3 pi. So therefore we have another arm here. And then bottom of pi will be taken to bottom of
3 pi.
3
Bottom
pi.
of 3 pi.
And then 0
0 to 2 pi.
0 to 2 pi. So we'll have another arm here. So I told you, because they are strict inequalities, you can as well put small open circles just at the ends to show that the endpoints are really not part of the solution. But even if you don't put them, you still mark it. So that is how we scale that. So the next part is now to find the Fourier series of the function. So we know that the Fourier series of the function is given by a naught over 2 plus summation n from 1 to infinity an cos of nx plus bn sine of nx. This by definition of Fourier series of any arbitrary function f of x. So a naught is given by 1 over pi. So remember, still we have been asked to define the Fourier series from minus pi to pi. So it's still from minus pi to pi of f of x dx. And then an is given by 1 over pi minus pi to pi f of x dx, cosine of nx dx. So n from 1, 2, 3, etc. Bn is 1 over pi minus pi to pi f of x sine of nx dx. N is 1, 2, 3. This is just the definition of the Fourier series of a function f of x, defined from minus pi to pi. So the work is on how to determine the Fourier coefficients a naught, an, and bn. You have to sharpen your integration techniques. So to get a naught, we'll have 1 over pi. So remember, if I'm moving from minus pi to pi, but our function has been defined by 2 formulas. There's a value from minus pi to 0, and then 0 to pi. And from your calculus, you know that if I call this a, this b, and this is c, integral from a to c of a function f of x is the same as integral from a to b, and then plus integral from b to c. So when you split the interval of integration, we can as well describe the integration from the endpoints by the summation of the 2 sub-intervals. So we'll have from minus pi to 0 of f of x dx plus 1 over pi from 0 to pi f of x dx. We will have as well done the integration from minus pi to pi, but we split it in 2 parts because the function is piecewisely defined. Now, what is the value of the function from minus pi to 0? Which formula do we use? Do we use 1 or 0?
1.
1. 1 is what is defined, or what defines the function when you are from minus pi to 0. So where there's f of x, we put 1 dx plus 1 over pi. Now from 0 to pi, which formula do we use?
0.
0. It was clearly given in the question itself. when you are integrating zero function, we get 0. So this part is like isn't there. So a naught is just 1 over pi minus pi to 0 of dx. Now, when you integrate 1 dx, what do you get?
X.
X.
You get x. Yeah. So therefore, we'll have 1 over pi into upper limit will give me 0 minus pi. So that means a naught is
1.
1, correct. So probably you get 1 mark up to that point. So next, an is 1
Scroll
over
up a
pi.
bit.
Okay. Up to that point. Up to what point?
There.
Oh, okay. You let me know when to scroll down.
You can scroll down.
Okay, fine. Then you also let me to whether you have completed so that I can write next step. Can I now continue? So we'll have 1 over pi minus pi to 0 f of x cosine of n x dx plus one over pi 0 to pi f of x cosine of nx we are doing this because the function has been defined by 2 different formulas on the domain from minus pi to pi. If it was just one value, then we'll just do one integration, taking care of all the endpoints of the limit. So which will be 1 over pi minus pi. When we are from minus pi to 0, the function is 1. And when we are from 0 to pi, the function is 0. What is the value of the second integral?
0.
0, because now we just have a 0 function there. So we remain with an is 1 over pi from minus pi to 0 of cos nx dx. Now, when you integrate cos of nx, what do you get?
Zero.
So remember, it was 0 when you already applied the limits from 0 to 2 pi. But now the value of the integral before you apply the limits.
1 over n sine of nx.
Correct. So we'll have simply, we can actually factor out n and then we write sine nx. That should make sense, okay? So, which will give us 1 over pi n. So the upper limit will be sine of 0 minus lower limit will be sine of a minus n pi. So sine of a negative angle is the same as
Negative sine theta.
negative sine theta. Remember, sine is an odd function. So which means we can remove the negative sign here. And so we'll have sine of 0 plus sine of pi n. And from our earlier discussion, the value of sine of pi n is
0.
0. So we'll have 1 over n pi and sine of 0.
Zero.
Is also 0. So 0 plus
0,
0
yeah.
by 1 over n pi.
Zero, I think.
0, correct. So an is 0. So we get our second mark. So lastly, bn. Bn 1 over pi, integral from minus pi to pi, f of x sine of nx dx. But our integral, our function has been split into two parts on the domain minus pi to pi. So we'll have minus pi to 0 plus 1 over pi 0 to pi f of x sine of n x dx. So according so that is the substitution. And of the two integrals, the easiest one to compute is these two integral. Which one is easier to compute?
Second one.
The second one, whose value is 0, because we'll be integrating a 0 function, yes. So that gives it. And I hope you understand why we are saying is 0. Why, when you integrate a definite integral for the function 0, you get 0. Now, Bn will be simply 1 over pi minus pi to 0 of sine nx dx. So which will be 1 over pi. Now, when you integrate sine function, sine nx produces
Negative 1 over n cos nx.
correct. So I can write n, and then I write negative, and then I write cos of nx. Okay. Hope that makes sense.
Yes.
Yeah. So now Bn will be -1 over n pi. So I put 0, I'll have cosine of 0. I put negative pi, I'll get negative cos, so negative n pi. But cosine of a negative angle is the same as
Cosine of a positive.
yeah, cosine of the same angle when it's positive. So which means Bn is minus. And what is cos of 0?
1.
1. So minus cos of n pi. And the value of cos of n pi?
1.
Also 1. So remember, I told you that these n values are 1, 2, 3, 4, 5, 6, or even you start from 0. 7, etc. So when you put 0 for n, the answer will be cos of 0.
1.
Will be 1. And then when n is 1, cos of pi,
Negative.
negative 1. And then when you put n equals to 2,
1.
1. When n is 3,
Negative 1.
negative. So this also this alternation of 1 and negative 1. And you get 1 when the power is even, and you get negative 1 when the power is odd. So we write this one as negative 1 over pi n into 1 minus, the value of this is -1 power n. Because all of us know that -1 power n will give us 2 answers depending on the value of the n, whether it is even or odd, which is with what you are getting with a few examples of n. So remember this -1, which is the same as the value of cosine of n pi, has 2 answers. 1 when n is even, -1 when n is odd. So generally the final answer you write in this form. So Bn, so when n is an even number, what will this bracket give us? What will be the answer inside the bracket when n is even?
0.
Will give us 0 because we'll have 1 minus 1, which is 0, because the value of -1 power n will give us +1. So we get 0. So 0 times this quantity?
0.
0. So this will be 0 when n is even. Now when n is odd, what will be the value in this bracket?
2.
Will give us 2 because we'll have 1 minus -1. Because the value of -1 power n is -1. So minus minus plus. So 1 plus 1 is 2. 2 times the outside value, -1 over pi n.
Negative 2 over pi n.
-2 over pi n. So this is the value for Bn. So we have all the values, so we can, in fact, you can actually try to generate some values of Bn. If I say this is n and this is Bn, I remember Bn starts from n equals to 1. So when Bn is, when the value of n is 1, Bn will give us
-2 over pi.
-2 over pi, because now 1 is an odd number, so we are going to use this formula here. When n is 2,
0.
0, because 2 is an even number. When n is 3,
-2 over 3 pi.
-2 over 3 pi, correct. When n is 4,
0.
0. When n is 5,
-2 over 5 pi.
correct. When n is 6,
0.
when n is 7,
-2 over 7 pi.
-2 over 7 pi. And actually, you can extend this list. But these are enough to make us get the final answer. So therefore, f of x is given by a naught over 2 plus summation n from 1 to infinity of an cos of nx plus bn sine of nx. And then we put in the values we have. So f of x, what was our answer for bn? Bn? Okay, a naught, not bn. So a naught from our computation is
1.
1. So 1 over 2 plus summation n from 1 to infinity. An
0.
0. So times cosine of nx. Bn, let me just write as bn and then sine of nx. So we not have the cos part, okay? Are you saying that this part will not be there?
Yes.
Yeah.
Yes, yes.
So just have the summation n from 1 to infinity of bn sine of nx. And you are mature at this point. You did series in engineering mathematics second year. So whereby if you are given a series in a summation form, you can always write it in expanded form. So this will mean we'll have a half. When n is 1, we'll have b1 sine of n as x plus b2 sine of 2x plus b3 sine of 3x plus b4 sine of 4x. I hope that one makes sense. If you write the summation in expanded form. Are you saying something that? When n is 1, so we'll have b1 sine 1 of x. Then from 1 you go to 2. So b2 sine 2x. From 2 you go to 3 up to infinity. Are we able to relate how I'm getting this part from here?
Yes.
Good. So then now we have the values of B1, B2, B3. So f of x is a half. What is the value of B1?
Minus
Just go to
2
the
over
table.
pi.
Minus 2 over pi. Then we multiply by sine of x.
Yeah.
And then B2,
0.
0. So 0 times sine of 2x. B3,
Minus 2 over 3 pi.
and then times sine of 3x. B4,
0 times sine of 4.
0. And then next term,
Minus 2 over 5 pi sine of 5x.
correct. And then followed by
0 sine 6x.
B6.
Yes, B6.
And then
0.
B7.
And minus 2 over 7 pi sine 7x.
Correct. And then plus other several terms, okay? So these even terms, this is 0, this is 0, this is 0. And what is common to the remaining odd terms?
Minus 2 over
Or terms
pi.
with minus 2 over pi. So we can factor out minus 2 over pi. So if I factor out minus 2 over pi, my first term will be
Sine x.
sine of x, followed by
Plus sine 3x.
then divided by 3, okay? Because we have a
Oh,
third
yeah,
here.
yes.
Yeah.
Yes.
So we have a third sine of 3x. And then next term,
Plus sine 5x or 5.
correct. Then next term,
Plus
1
sine
over
7x.
7. Yes.
Oh.
In fact, you can even predict the next term, okay? So you know how the series is. So this is the required series. So you get 4 marks up to that point. Have we exhausted all the parts of the question? We haven't. So the last part was to find the value of the series. What are the first term of the series? We were to use this answer in B to solve some part in C. And the series in C was
1 minus a
One
third
minus
plus a fifth
1
minus
minus a third, and then
plus a fifth
plus a fifth, and then
minus 1 over
minus
7.
7, yes, plus other terms. So here is where you make the use of your sense of sight to get some pattern from the series and probably what you're supposed to do. Forget about the signs and check the values we have in the brackets and the series that we have to get its closed form. Are you able to see some similarity in what is in the square brackets and what we have?
Yes.
Yeah, you can see like there's a third here. There's a 7. Okay. So which means then if remember this series is sine of x, and then you have a third sine 3x, and then we have a fifth sine 5x, and then we have 1/7 sine 7x plus other terms. That is what is in the square bracket in part B. So which means if we can reduce this to 1, we reduce this second term to minus a third, we reduce this to 1/5, we reduce this to minus 1/7, then we will be able to determine the value of this series given. So the question is, what value of x can produce this which value of x will be in such a way that when we put into the series in B, we'll make the value of sine of x to be 1, make the value of a third sine 3x to be minus a third, same value of x to make value of 1/5 sine 5x to be positive 1/5, and the same value of x to make 1/7 sine 7x to be minus 1/7.
Pi over 2.
Pi over 2. So let's see. So it's like we need a condition that makes the first value to give us 1. So this means x is sine inverse of 1. So you say the answer is pi over 2. So if you fix pi over 2, then the first two terms will agree. Is it true that also the second term will also agree? If you put 90 where there's x, 90 degrees, if you multiply a third by sine of 3 times 90 degrees, does it give you negative a third?
Yeah.
And then is it true that sine of 5 pi over 2 is the same as 1?
Yes, yes.
Does it also work for the next term, sine 7x?
Yes, yes, it works.
All right, good. So if that works, then it means that we are going to replace in the series in B, everywhere there's x, put pi over 2. Because if we put pi over 2, then we'll get, in that equation, we'll get a series which is exactly the same as what you have to solve. So therefore, we say let x to be pi over 2. Then B becomes if where there's x we are putting pi over 2 will be the same as a half minus 2 over pi into sine of pi over 2 plus a third sine of 3 pi over 2 plus a fifth sine of 5 pi over 2 plus a seventh sine of 7 pi over 2. An interesting question. What is the value of f of pi over 2? From the definition of the function, which formula defines f at pi over 2? Is it formula 1 or formula 2?
2.
2, second one.
Formula 2, because 2 is what gives the value of x from 0 to pi, okay? So if you want to define a value when x is pi over 2, remember pi over 2 is between 0 and pi. So and in the second formula, the value of f of x is? So this is what I'm saying. This is the formula I'm referring to.
0.
Remember, these were the function. So always f of x will be 0 whenever the value of x is from 0 to pi. And because a half is in the interval 0 to pi, then the value of the function will be 0. So therefore, we'll have 0 equals to a half minus 2 over pi. And from our analysis, we have found out that this will give us 1. This will give us minus a third. The next term will give us 1 over 5. Next term will be minus 1 over 7, plus other several terms of the same kind. So to get the value of the series is just to make the series the subject of the formula. So you're taking this to the left, I'll have 2 over pi, 1 minus a third, plus 1 over 5, minus 1 over 7. Should give me
1 over 2.
1 over 2. So which implies 1 minus a third plus 1 over 5 minus 1 over 7. What the exact value of that series?
Pi over 4.
So pi over 4. So that's what we get in that given case.